Hello everyone! I am Teacher Mercy. Today we will discuss about the properties of trapezoids and theorems related to trapezoids. Are you now ready? Here we go.
How do you call a quadrilateral with exactly one pair of parallel sides? It is called a trapezoid. Quadrilateral hope is a trapezoid. Segment HO and segment EP are parallel, and they are called the bases of a trapezoid. Segment HE and segment OP are the non-parallel sides of a trapezoid, and they are called the legs of a trapezoid. The angles formed by a base and a leg are called the base angles. Angle E and angle P, angle H and angle O are called base angles. The sum of the angles of a trapezoid is 360 degrees. Segment HD is an altitude of a trapezoid. Altitude or the height of a trapezoid. What is this altitude or height of a trapezoid? It is any segment from a point on one base perpendicular to the line containing the other base. Let us consider quadrilateral HOPE or quadrilateral hope. If we connect the midpoints of segment HE and segment OP, a line segment is formed. Let us call this segment MD. The segment joining the midpoints of the legs is called the median of a trapezoid. Segment MD is called the median of a trapezoid. And we have now the theorem. The median of a trapezoid is parallel to its base, and its length is 1/2 the sum of the lengths of the bases. If segment MD is a median of a trapezoid HOPE or hope, then segment HO is parallel to segment MD and is parallel to segment EP. And MD, or the median of this trapezoid, is determined by this formula 1/2 times the quantity HO plus EP. So we have to add the lengths of the two bases.
Let us apply the theorem in this example. Given, quadrilateral hope is a trapezoid with median MD. Number 1. If HO equals 16 and EP equals 26, find MD. How do you solve for MD? So, applying the theorem, we have the median is equal to 1/2 of the sum of the bases. So, substitute the given to this equation. So, we have 1/2 times the quantity 16 plus 26. Then, combine 16 and 26, it becomes 42. 42 times 1/2 or 42 divided by 2 equals 21. So, the median or MD equals 21. Number 2. If HO equals 2x plus 3 and MD equals 15 and EP equals 4x minus 9, find x. So how do you solve for x? So from the theorem or applying the theorem, so we have MD equals 1/2 of the sum of the bases. So substitute the given to the equation. So we have 15 equals 1/2 times the quantity 2x plus 3 plus 4x minus 9. Then combine 2x plus 3 and 4x minus 9. The result is 6x minus 6. So we have the equation of 15 is equal to 1/2 times the quantity 6x minus 6. Multiply both sides by 2. Then it will be 2 times 15 is 30. 1/2 times the quantity 6x minus 6 times 2 is 6x minus 6. Then we have using or applying addition property of equality. So we have 30 minus 6 equals 6x. Then divide both sides by 6 to solve for x. So we have 24 divided by 6 equals 6x divided by 6. The result is x equals 4. What if the legs of the trapezoid are congruent? How do you call this trapezoid? It is called an isosceles trapezoid. Is quadrilateral love an isosceles trapezoid? The answer is yes, since the legs LE and OB are congruent based on the illustration. And we have segment LO and segment EV are parallel. Here are the theorems of the isosceles trapezoid. So we have the base angles of an isosceles trapezoid are congruent. Opposite angles of an isosceles trapezoid are supplementary. And diagonals of an isosceles trapezoid are congruent. Consider these illustrative examples. We have the theorem, the base angles of an isosceles trapezoid are congruent. So if angle L is 110 degrees, then angle O will also be 110 degrees. Now, angle E will, if angle E is 70 degrees, then angle V will also be 70 degrees. That is based on the theorem. Now another theorem is opposite angles of an isosceles trapezoid are supplementary. So the opposite of angle L is angle V. The opposite of angle O is angle E. So if angle L is 110 degrees, then angle V is equal to 70 degrees. Why? Since according to the theorem, opposite angles of an isosceles trapezoid are supplementary. So when we say supplementary, the sum of the two angles is 180 degrees. So if angle O is 110 degrees, then angle E is also 70 degrees. So since angle E and angle O are opposite angles. Let's have the third theorem. Diagonals of an isosceles trapezoid are congruent. If we connect the opposite vertices L and V, segment LV is formed. Then the vertices E and O, segment EO is formed. So, segment LV and segment EO are diagonals of trapezoid LOVE or trapezoid love. So if LV equals 20 centimeters, then EO is also equal to 20 centimeters because they are diagonals of the trapezoid, and according to the theorem, diagonals of an isosceles trapezoid are congruent.
Let us apply these theorems in this problem. Quadrilateral CARE or quadrilateral CARE is an isosceles trapezoid. the given. If the measure of angle ACE equals 2x plus 5 and the measure of angle ARE equals 3x plus 10, find x. How do we solve this? Since angle ACE and angle ARE are opposite angles, then we can apply the theorem, opposite angles of an isosceles trapezoid are supplementary. So these two angles will have a sum of 180 degrees. Our equation will be 2x plus 5 plus 3x plus 10 equals 180 degrees. So by combining like terms, we have 5x plus 15 equals 180. Then, applying addition property of equality, it will become 5x equals 180 minus 15. Then 5x equals 165. Divide both sides by 5. Then x equals 33. Then we will substitute this value of x which is 33 to the measure of angle ACE which is 2x plus 5. So it will become 2 times 33 plus 5 and it is 66 plus 5. So the measure of angle ACE equals 71. What about the measure of angle ARE? So again, substitute this value 33 to x. So it will be 3 times 33 plus 10 equals 99 plus 10. The measure of angle ACE equals 109. So if we are going to add 71 and 109, the sum is 180 degrees. So that is the measure or angle ACE is supplementary to angle ARE, or these two angles are supplementary. Another example. Quadrilateral care is an isosceles trapezoid. The given CE equals 6x minus 2 and AR equals 3x plus 13. Find x. What theorem can be applied to answer this problem? Since segment CE and segment AR are legs of an isosceles trapezoid, so we can state that segment CE is congruent to segment AR. And it follows that their measures are equal. So CE equals AR. Then substitute these values, value of CE to value 6x minus 2 to CE and 3x plus 13 to AR. So the equation becomes 6x minus 2 equals 3x plus 13. Then combine like terms and apply addition property of equality. It will be 6x minus 3x equals 13 plus 2. Then simplify. It will become 3x equals 15. Divide both sides by 3. Then x equals 5. Let us substitute this value 5 to CE and AR. It will be 6 times 5 minus 2 for CE and 3 times 5 plus 13 for AR. So the result is 30 minus 2 equals 15 plus 13. Then the measure CE is 28 while AR is 28. So in this case, since they are legs of this isosceles trapezoid, so their measures are equal. Here's another example. So we have quadrilateral care is an isosceles trapezoid. CR is a diagonal and AE is another diagonal. Then we have a given here. CR is equal to x plus 5 and AE equals 3x minus 7. Find x. So how are we going to solve this? What theorem applies in this problem? Since quadrilateral care is an isosceles trapezoid, so their diagonals are congruent. So we can state that segment CR is congruent to segment AE. So if they are congruent, so their measures are also equal. So we can have the equation CR equals AE. Then substitute CR with x plus 5 and AE with 3x minus 7. Then we have the equation x plus 5 equals 3x minus 7. Then solve for x. Then by combining like terms, we have x minus 3x is equal to negative 7 minus 5, applying also the addition property of equality. So we have negative 2x equals negative 12. Then divide both sides by negative 2. Then x is equal to 6. Let us substitute this value 6 to the measure of CR, which is x plus 5, and AE, which is 3x minus 7. So we have 6 plus 5, and for AE is 3 times 6 minus 7. So CR has a measure of 11, while AE, which is 18 minus 7, is also equal to 11. So therefore, CR is equal to 11 and AE equals 11. So in this case, the diagonals have the same measure, so they are CR and AE are congruent. How about finding the area of a trapezoid? In the given figure, quadrilateral LOBE is an isosceles trapezoid. So suppose the length of the bases are 10 meters and 20 meters, and its height or altitude is 8 meters. What is the area of this trapezoid? How are we going to find the area? To find the area of the trapezoid, we will use the formula. The area is equal to 1/2 of the sum of the lengths of the bases times the altitude or the height. Then we have A is equal to 1/2 times the length LO and the length EV times the length LD or the height. So in this case, substitute the given to the equation or to the formula. So we have A is equal to 1/2 times the quantity 10 meters plus 20 meters times 8 meters. Then we have A is equal to 1/2 times 30 meters times 8 meters. Then multiply 30 and 8, so we have 240 square meters times 1/2, so we have 120 square meters. So this is the area of this particular trapezoid. That's all for this lesson. I hope you learned something from this, and thank you very much for listening. So if you have not subscribed yet in this channel, please click the subscribe button and the notification bell so that you will be updated with our upcoming videos. Again, this is Teacher Mercy. Have fun learning math.